everyone. I am Adiola, and I'm currently a data scientist, solutions architect at NVIDIA. I'm working on helping NVIDIA partners to accelerate their data science processes with GPUs, and also solving training and inferencing challenges in deep learning and machine learning to ensure that data scientists have the time to develop products that their client can use, and also like shorten their process and training inference time using GPU acceleration. So today I'm here to talk about an overview of Rapids for GPU acceleration. And most of what I'll be covering, I know like I'm speaking to a group of experts already who have used Rapids before, but I would just like share my knowledge of what I've understood about using Rapids to accelerate your data science workflow, your deep learning workflow, your machine learning workflow, and also talk about a very important Rapids use case or Rapids library, which is for computer vision and image processing. So thank you so much for inviting me to come talk to you today and share my knowledge. So just move right on into the agenda for today. So we have like, the agenda. I already introduced myself, and this is an overview of Rapids. Then we'll look at how we can get started with Rapids on single GPU and also on multiple GPUs, focusing on Dask for parallel processing specifically. And then we'll look at Rapids for image processing, which also extends into computer vision. And then I will just talk about, I may not be able to show all the full work, about the Rapids, especially because it's just like the basics, which you're already aware of, and also about Dask. Then if there's time, if there is opportunity to take your questions and answers after now, then we'll look at that too. So like I mentioned, the essence of Rapids is to bring agility to data science. So we see like many companies over the world are, especially in this highly challenging environment, are looking for ways to attract and retain users. They want customers to come back to, to use their product, to, buy from their company. They want to keep their customer on a long term. And then they continue to churn out products, recommend products. So if you look at your recommendation, companies like Netflix, they recommend new movies to users. You look at Walmart or Kroger or e-commerce companies, they recommend new products to their customers. Even when you go online after shopping for a particular item, other interested or similar items are recommended to you. And the idea is that we want the customers to keep coming back. And all this is powered by data science, accelerated workflows with GPUs. So companies that don't accelerate the workflow process, that is, there's a lag between how much time your customer clicks and buy a product. Then they will see themselves on the other side while their competitors, keep taking the larger share of the market. So with Rapids, the idea is to enable data science companies and data scientists and developers to be able to accelerate their workflows, especially in the AI world, and also create more interesting digital experiences to obtain customer loyalty, and also to power AI intelligent stores. So you want your customers to come to your store, they can scan, with a barcode, they can take images of what they are like, and then they can check out immediately. So that is the essence of, bringing agility to data science. And we want to also ensure that our customers or whoever uses Rapids SDK is able to generate, less hardware power consumption. So versus using CPUs that take longer time to train your forecasting model or to train your time series model, you can utilize that on GPUs, and then you consume, less hardware power, and then you also have lesser time for training and inferencing for your model. And on the long side, of course, you reduce your overhead costs and then also retain and attract customers. So this is what a typical data science workflow looks like. It's not always easy. So from the data collection to the exploratory data analysis, up to feature engineering. So, of course, as developers, as data scientists, you have to collect your data, you have to explore what the data is talking about, you have to, engineer some features, look at what are important features for me to be able to make the best recommendations to my customers, or what are the best features that would ensure that the computer vision model that I'm putting out, is capturing the key objectives that I really want the users of those models to really work with. And then you have to tune it, you have to evaluate those models, you have to train them, and then you export this model. Of course, you can have different version of the model as you train it, and they begin to learn well. As your model begin to learn well, you have different versions of it. And then you have to put them into production, either through batch modeling or dynamic modeling, and then you put them online. So by the time they are turned online or they are put online, that's when your end users are able to use them. However, we see some problems with this, which is like slow CPU process, and also especially when there's big data involved. So as people use the data, as the population continues to keep growing, of course, as the expansion of digital and online media continues to grow, you have more access to data. So if you have big data and you're working on CPU powered platforms, of course, there's always a challenge. So you have to keep going, you have to keep going to do data collection, explore more data. And then that's where the problem comes from. So now this is where Rapid comes in. So Rapid is, of course, is a, open source data science ecosystem, and they consist of familiar Python APIs that data scientists nowadays already uses. So like, you don't have to go through a steep learning curve to come over, to use Rapid or to be a Rapid user. So you have the same process of data preparation. You train your model and then you do the data visualization. And these are below are common libraries that data scientists uses. So you have pandas for your analytics processes, you scikit-learn for machine learning processing. And then if you are a graph neural network person, or you're interested in deep learning, like graph neural networks, of course, in Python or in current Python APIs, you have NetworkX for graphics analytics. Then you have for deep learning, you have PyTorch, TensorFlow for your deep learning processes, and then Matplotlib, which is a common one for data visualization. However, all this runs on CPU memory. Imagine running all through all these very heavy models on CPU. I've done that before when I started with data science, and sometimes it takes hours to train a deep learning model. And all this works on CPU memory. However, for Rapids, we provide an end-to-end GPU accelerated data science process. You're still going through the familiar APIs, familiar processes that you're used to, from data preparation to model training to visualization. However, for here, instead of CPU memory, all your processes are done on the GPU memory. And Rapid uses the Apache Arrow method because it helps to format faster data loading on the GPU. So for pandas, in place of pandas, you have like cuDF, which is the infrastructure for analytics similar to pandas. And then you have the cuML for machine learning processes. We also have cuGraph in place of NetworkX, which is the familiar Python API that you're used to. You use cuGraph. And then for PyTorch and TensorFlow and MSNet, the same thing for deep learning. And instead of using this Matplotlib for CPU memory usage only, you can use QSFilter, PyVis, or Plotly for your visualization. And then an addition for this is Dask or Spark. So if you're a big data scientist, you're utilizing big data every now and then in your workflow processes, then Dask for parallel data distribution is the best one to use. So now, I won't be talking or showing everything on this Rapid component, but I'll be talking about two particular ones. So we have for the data preparation and ETL process on the Rapids, like I mentioned, I don't want us to forget this. They are familiar Python APIs that you use. The only thing that you need is just a code chain, which I'll be showing in subsequent slides. For data preparation and ETL process, you have the cuDF library that is part of Rapid, which is GPU accelerated ETL function. And it's similar to Pandas and other core PyData APIs. And then you can even utilize cuDF in your Dask integration for scaling your data for scaling your data preparation and ETL processes. Another aspect of the Rapid is the Rapid machine learning library. So these are GPU accelerated libraries, like the cuML library. You can also use it for common machine learning algorithms like XGBoost, Forest Inference Library, high performance optimization, and more. Then for the graph aspect, I mentioned earlier that you use NetworkX, which is a similar Python API. However, cuGraph is the GPU accelerated library component for Rapid, where you can run your graph analytics on GPU and include other aspects of it as well. We have for visualization cuFilter. It accelerates your cross-filtering, especially for big data. And I've seen this used in various projects that utilize spatial analytics or geospatial analytics. Then you can even integrate PyVis into cuElseFilter, like your bokeh, your plotly dash, and so on. Now, when we talk about the domain-specific libraries for Rapids, so we have the one, so if you're a cybersecurity data scientist, where you study anomaly detection or things that are going around in cybersecurity logs, we have the Morpheus library for Rapids. Then if you're streaming big data every day, you can use the cuStream, and then cuSignal for signal processing, the cuSpatial for spatial analytics. And the interesting one I'll be talking about today is the cuCHIM. So this is a library, a GPU accelerated rapid function that is based on computer vision and image processing. So I'll be talking about that to us as well today. So all these components aid in faster data loading and parallelization on GPUs, which leads to faster training time. I mentioned one key interesting benefit of using Rapids in your data science workflow is that it helps in accelerating your process from data loading, from your ETL processes, from every aspect of your data science process. You see like reduced time in training, in inferencing, in benchmarking, and in performance. As I mentioned earlier, there's no steep learning curve in transitioning from what you're used to, the familiar Python APIs you're used to, and using rapid GPU accelerated libraries. You see that there are just minor code changes that you need to do. From looking at the upper part is talking about the GPU, the CPU process, while the lower part is talking about the GPU accelerated libraries. And all you need to do is just change your code. So for like pandas, when using CPU, you just import pandas as PD, and then you read in your CSV file. So this GPU, and then you just import your cuDF in place of pandas. The same thing for Dask. So Dask also utilizes CuPy or utilizes cuDF. So you just do the Dask cuDF library in place of just Dask distributed from client. Scikit-learn is same thing. You just change it to cuML, right? And for NetworkX, you just import your cuGraph. So, but average speed in data loading alone is up to 50 times for cuML and up to 250 times on GPU versus when you use NetworkX on CPU for NetworkX. And then the one I didn't show here, which I will show later, is for the image processing aspect. So for CPU aspect, you have the scikit-image. So anywhere you see scikit-image on the CPU aspect for computer vision or image processes, you can utilize cuCHIM. So cuCHIM is for the GPU and rapid accelerated library for computer vision and image processing. So aside from providing image processing functions for cuCHIM, it also provides to image and data readers, to address the common bottlenecks in deep learning training scenarios. And cuCHIM also, support Python APIs for reading T files, with an API that match OpenSlide library or even scikit-image library. So like the main benefit I wanted to show from this is that they're just trivial code changes, right? Trivial code changes. You don't have to like change all of your code to utilize the Rapid libraries. So like I said, for each of these libraries, you have like faster improvement in training times. So we have faster data access, and also your data have less movement. So because if you're moving data from one place to the other, you can cause data leakage. So if you're using the normal familiar Python API, all on CPU or reading from disk, you have 25 to you have like 25 to 100 times improvement, right? However, on Rapid, you have 50 to 100 times improvement using the same code, flexible language, all primarily on GPUs. So yeah. So this is just like iterating everything again, like accelerate on single GPUs, Rapid and others, your NumPy, the familiar NumPy. It's something as SchoolPy, Pandas, cuDF, Scikit-learn, you use SchoolML, and then NetworkX, use SchoolGraph, if you want to accelerate on GPU. So I'm not sure I should dwell so much on getting started with XGBoost on GPUs because you all are data scientists, but XGBoost is just is supervised learning approach, where you use assembles of decision and regression trees to estimate functions of each data sample. As we all know, XGBoost is a tool of choice in multiple machine learning competitions, and it can be optimized for distributed training on multi-core systems. One of the reasons why we use XGBoost on GPUs, especially for Rapids, where you utilize your cuML library for machine learning, that XGBoost can be time consuming to run. Your task can take from hours to days to complete. Of course, you have to tune your upper parameters for higher accuracy, high throughput and low latency, and so many more like that. So but however, doing this on GPUs can lead to decrease in training times, and then you can also use GPU to do all the process in parallel for all the given nodes and features at every tree level. So yeah, it's just to show why you should use like your machine learning process. For example, XGBoost on GPUs. Number one, you have like faster data access, less data movement. So this was benchmarked on a GPU A100, 16 gig, 16 this one 16 A100 GPUs, 40 gig each. And then you see that you have between loading and cleansing a data set and doing feature engineering and training a classifier using a 200 gigabyte CSV data set. A Rapid-based pipeline, completed this operation in just over 2 minutes. This same process, takes 2.5 hours on a similar CPU configuration. So it's just to tell you that, running your processes, machine learning processes, even for your competitions, for your data science competitions, and for even your day-to-day workflows, reduces training time. It increases your training time using GPUs. So, and one of the reasons why I wanted to highlight this is also that our team at NVIDIA also won the ACM Recommendation System Challenge in 2020, using GPUs and, utilizing XGBoost, combined with GPUs. We're able to train over 200 million interactions or features within 2 minutes, 18 seconds, right? Just 25 times faster than doing that on a CPU. Now let's talk about distributed process on Rapids. This is where Dask comes in. So Dask, so if you're doing like XGBoost or random forest or other machine learning processes, you can utilize single GPUs, like one GPUs, depending on what your data look like. However, if you have like bigger data, like almost 300 gig worth of data, you might have to like distribute them, on distribute and scale them using Dask. And Rapid also is integrable with Dask. So we said that multiple GPUs is equal to utilizing Rapid's platform with Dask. Please be reminded that Rapid is the accelerated platform for data science processes. Familiar with Python, the normal Python data processes that you do. So why Dask? So Dask, support distributed data frames to scale them seamlessly. And for you have like data frame pandas using pandas or cuDF. So pandas is the Python one, cuDF is the Rapid aspect. But Dask data frame support both type. However, it helps you to like partition and separate your processes on different GPU, like different processes. However, they're running at the same time. So you don't have to wait for one to finish before the other, right? So that's like support, just like what Dask is doing. It also is similar to what computer vision, like using computer vision on the Cushing library on Rapid, to support blockwise image processing, illustrating distributed processing across multiple GPUs. And then you have the task enabler, like that enables efficient compute on Dask. So if you have big data, you don't have to wait for one session of data to finish processing before the other. You can distribute the data on different GPUs, right? And then it completes, it trains, it does the inferencing, and then your model, you have your model on another GPU, and then you're able to compute and persist, those workflows at the same time. So now with Rapid, right, you can do like, you can scale out, you can parallelize your data, and then, with Rapid, you can utilize the cuML function, the cuDF function, all with that. They are all integrable with Dask. You can do like much distributed processing on Dask. So everything, all these are integrable with Dask. So like if you want to optimize your Dask processes even faster, then do them on GPUs. Of course, Dask is already like a process to scale your workflow. However, if you want to see faster training times versus utilizing them on CPU, pure CPU, right, then you need to bring your processes with Dask on GPU. What else? So I'm gonna show us, a demo at the end. So not like a demo because I'm not going to be running it. I just wanted to see what the code changes look like for both for Dask and for the machine learning aspect. So this is like an internal workflow that we do at NVIDIA. So if you're like an NVIDIA client, you have access to some of these processes. However, the Rapids.ai website is also a very good source, a very good documentation or platform where you can have access to the basic GitHub notebooks where you can experiment with Rapids. So now, this is the Rapid with Cushing. So Rapid with Cushing, which is the computer vision and which is computer vision and image processing aspects, for GPU accelerated process for image processing and computer vision. And I especially want to mention it because I know some of the members are interested in computer vision. They wanted to see how they can incorporate Rapid into their computer vision and image processing project. So Rapid Cushing is an extensible toolkit, right, that is designed to provide GPU accelerated I/O, computer vision and image processing primitives for n-dimensional images. However, with a focus on biomedical imaging. So I've been trying to get like something different from image processing, but like I wasn't able. But I just want you to know that Cushing, like the Rapid with Cushing, which is a Rapid library, can be utilized anywhere. You can use scikit-image. So I know some of the data scientists that are listening to this already like worked on computer vision projects. So anyway you can use scikit-image, you can use the Kushim library as well. So just like what I showed earlier about, just changing code, like trivial code changes from Python to cuDF, from Pandas to cuDF, from scikit-learn to cuML, from NetworkX to cuGraph. The same thing applies to Kuchim, right? So like if on the screen, we have like a two contrasts of how scikit-image scikit-image for image processing and, Kuchim for image processing works. Just little code change. So you say from scikit-image import data and all the other methods you want to use, and then from Kuchim import cuimage, and then you load in your image file. Like I mentioned earlier, the Kuchim library supports TIFF format, and then you just like continue that way. So this is a GitHub link that I will show, after the presentation, just to show you like the basic usage, especially for image data in healthcare. So like I mentioned, this Kuchim was developed with a focus on biomedical
Are you going
imaging.
for a notebook?
What did you say? Okay, so one of the primary objectives for Kuchim is to provide open source implementations of a wide range of CUDA accelerated n-dimensional image processing operations. So like I mentioned, the Kuchim API, it mirrors or is kind of familiar to scikit-image, which is a collection of algorithms for image processing, for image manipulation, and OpenSlide for image learning. So like it's a very familiar Python API, and data scientists are able to use it. They can port from existing base CPU codes to GPU, just like that. So on the screen, you can see that you can utilize, so this utilizes the CuPy. So if you are familiar with NumPy in Python, then the similar library in Rapid is the CuPy. So CuPy is the image processing aspect for Rapid utilizes CuPy. So the GPU-based scikit-image API is provided in Kuchim.skymage module, which I will show us in the GitHub link that I will show later. So CuPy was chosen, like I said, is the opposite of NumPy in the familiar Python API you're used to. So it was chosen because it provides an equivalent GPU method for NumPy, and it's also a subset of SkyPy, of course. So for you to be able to utilize Kuchim for your computer vision or image processing project, you need to install it. So there's a lot of installation notes on the rapid.ai website. So when you go through, you see the different libraries and you go to Kuchim, it tells you how to install them. So like, for example, if you don't have like, if you don't have access to the, NGC, so we call it base command platform, or NGC, the registry container like that NVIDIA uses, you can also install them through is it PyPy? I know, like there's a PyPy installation. So you just pipe install Kuchim, and then you also have to, have Docker downloaded if you want to use the GPU aspect of CUDA, right? CUDA 11.0 and later, like the latest CUDA version installed. And then you have a lot of data set you can play with. You can, just explore how Kuchim works after installing. But I will show us as soon as I'm done with the slide. So at the end of the day, getting started with Rapid is very easy, as some of you may have known, right? And then you can just go to, there's a Rapid community notebook on github.com. You can just search for it. When you go to rapid.ai website, you see the GitHub link, how to get started. There are different tutorials. And if you also want to contribute to Rapid, it will also be there, So I'll stop sharing and then show us the GitHub link for the Kushim one, so you can see what I'm talking about. One second, please. Okay. Let me reshare my screen. Okay.
It's visible.
Can you see my screen?
Yeah.
Yeah, so like I said, Rapids.ai website, they have different GitHub links or different notebooks where you can see just basic image. Like I mentioned, anywhere you see the scikit, anywhere you have used scikit image, you can use the Kushim library, which is a GPU accelerated platform, all on your Jupyter notebook. Like you don't have to install something different, to be able to use Kushim. So if you have like, even on Google Colab, you can do it on Google Colab. So Rapid is supported on Google Colab as well. So here, you can install either with pip or with Conda, depending on what you use, either through Anaconda. So Rapid is also available on Anaconda, right? So you install those dependencies that you have to install, and then you can read your image. So like the other one I showed, you said from scikit image, right? But this one is from Kuchim, because you're just doing the opposite. So just importing this alone is GPU accelerated. It's a GPU accelerated function for your computer imaging, computer vision image processing. So this is an image that was read into using the co-image function, and then you can see the metadata of the JSON data file, and then these are the the metadata that was done. So we can see that this is using CPU. So I will show below what the GPU aspect look like. And here you have the different dimensions, or this is talking about color, RGB, and then it's talking about the different dimensions of the data set. Then you see the image size at 256, and then you see the associated images, just the data, metadata of what the file looks like. So now it's talking about, this reading the region of the data. Like I mentioned earlier, Image support different data format. So now I mentioned TIFF. However, here it's mentioned that you can save the image in a .ppm format, and you can open the image and to see what it looks like. So, like I mentioned, Kushim was majorly developed for biomedical imaging. So you will see a lot of the use case majorly in the healthcare sector. However, like I said, if you have other computer vision projects you've done before, you can easily like code change from using CPU method in your computer vision or image processing project to the rapid accelerated version of scikit image, which is co-image. So reading the region, you can save it as a PPM file. So this is just, this looks like a biomedical image. I don't know much about biomedical images, but at least you can see the image, you can see the, the different areas that in green. So now, like I mentioned, like when you're using CPU, of course, you import NumPy as MP, but co-image for GPU accelerated aspect uses their CuPy, which is the accelerated version of NumPy. So you can see the shape, you can see the data. So this is still using the NumPy aspect, but we'll see the corresponding GPU memory down there. So yeah, so here we have imported CuPy as CP in place of importing NumPy as NP. So this is an array-like object. We can convert it to CuPy array through using the cp.array, calling that method on the object that you're interested in. So this code now shows you how to load an image to GPU memory and then visualize it, either in your Jupyter Notebook or your Google Colab. So you have already shown how what's it called? They have to do it in NumPy. But here, for you to be able to do it on a GPU memory, then you have to import CuPy as CP. I mentioned in the presentation that the Kuchim utilizes CuPy because it is the GPU accelerated version of NumPy, which image processing uses and utilizes as a CUDA array function. And then you just, so this is the major thing you need for you to get your image processing functions on the GPU memory. You have to import CuPy and CP, and then import Kuchim from the CuA image function. And then you proceed with your, looking at the image and then converting your array to, a CuPy array. So that's like the most basic thing you can do with cuImage. I wish I could show us a more advanced use case for using Kuchim, but this is all I can get right now. But like I said, as data scientists, wherever you can use a scikit image, wherever you can use your NumPy, you can utilize Kuchim, and then utilize CuPy to be able to accelerate your image processing project on the GPU side. So that is the end of my presentation. I really hope this has convinced you to, try out Rapid, try out all the libraries in Rapid, for all your use cases, from the cybersecurity project to your machine learning project, to your graph neural network project, to your deep learning project, and even to your image processing project. There's so much benefit of using GPUs. So if you want to cut down on your training time, you want to train your models faster, you want to put them, you want to push out the online version faster, and you want people to be able to access it and, get to your audience, then you need to go on a GPU. You consume less hardware memory, and you also scale your processes faster. All using Rapids for GPU acceleration workflow. So thank you so much for listening. I hope this has been useful for you. Questions or clarification?
Yeah, we'll be able to give you the questions, and of course we can get it as a short video afterwards as well. So since India time is very vague, we had to just get the recording done. So I'll get the questions as soon as possible to you now.
All right, great. I'm sure you're gonna let me stop recording.
Yeah.